Hi everyone. So today we're going to look at another formula for gradient. So we already are aware that when we have a straight line, we can find the slope of that straight line by dividing its vertical height by its horizontal height. So the first formula we've ever actually done is the gradient formula using V and H. Then later on we used coordinates, and using coordinates we found that vertical height is the same as y2 minus y1 and horizontal height is the same as x2 minus x1. So we can easily replace the gradient formula by y2 minus y1 over x2 minus x1. Today we're going to look at another formula we can potentially use, and that involves using the angle that the line makes with the positive direction of x-axis. So this straight line, this red line, is making an angle theta with the positive direction of x-axis. So if you look at the right angle triangle that we have got in front of us, I'm just going to draw that right angle triangle here. This angle is theta, this is y2 minus y1, this side is x2 minus x1. As we can clearly see, this is a right angle triangle. So using sine, cos and tan ratios, and theta being where it is, I can see that opposite from theta is O, side adjacent to theta is A, and this side is hypotenuse. So if I were to find tan theta, that will be opposite over adjacent, which will be y2 minus y1 over x2 minus x1, and that we know full well is the gradient. And from there we get another formula for gradient, which is m equals to tan theta, and theta is the angle that the line makes with the positive direction of x-axis. So keeping that in mind, let's have a look at this example, which is asking us to calculate the gradient to one decimal place of a straight line ST, which makes an angle of 60 degrees with the positive direction of x-axis. So we know full well that, and we've just established, the gradient is m equals to tan theta, and we know the angle is 60 degrees. So we'll write m equals to tan 60 degrees. And then just using our calculators, we can calculate tan 60, which is 1.7, and that is up to one decimal place.